Alright, so in this video I'm going over the chapters 5 review. The first question wants me to add or subtract as indicated. There is a negative sign right here, so I want to first go ahead and distribute that out. So I'm going to change all of the signs after that negative sign. Then I want to combine like terms. So I have a 7, a 5, and a negative 9 that are all real numbers. 7 plus 5 is 12, minus 9 is 3. And then I am going to add this 2i and this 8i together to get 10i. Number 2, same idea. I want to go ahead and distribute that negative. So this is going to become positive, this is going to become positive, and this last term is going to become negative. Then I want to go ahead and combine like terms. I always start off with my 12, or not my 12, my real numbers when writing with complex numbers. So 12 is going to go out front. And then my imaginary numbers get added together and put at the end. So I have 3i and negative 4i. 3 minus 4 gets me negative I. Number 3 wants me to multiply and then write my answer in standard form. So I'm going to distribute 3i times 2 gets me 6i. 3i times 4i is going to get me 12i squared. Remember, whenever I have I squared, this gets replaced with negative 1. So then if I multiply this together, it's going to give me negative 12, but that is my real part, so real parts always come first. So I'm going to have negative 12 plus 6i. Number 4 wants me to find the product again and write my answer in standard form. This one, I have two binomials being multiplied together, so I'm going to FOIL. Remember, F stands for first, so I'm going to multiply my first terms together. 2 times negative 4 gets me negative 8. Then the O in FOIL stands for outside, so I'm going to multiply the two outside pieces together. 2 times negative 6i gets negative 12i. Then I have inside, so then I have 4i times negative 4, which gets me negative 16i. And then I have 4i times 6i, which is going to give me 24i squared. I want to go ahead and combine like terms. So I have 2 i's in the middle. This is going to give me negative 28 when I add negative 12 and negative 16 together. And it's still plus the 24i squared. I can go ahead and replace that I squared with a negative 1. Then I want to go ahead and multiply that 24 and the negative 1. It gets me negative 24. Then I just need to put my two real numbers together, so negative 8 and negative 24 gets me negative 32 minus 28. So the next question wants me to divide and express the result in standard form. Basically what this is rationalizing my denominator. So I want to go ahead and multiply the top and bottom by 3 plus I, which is going to get me on the top 23 times 3 gets me 69i. And then 23i times I is going to get me 23i squared. Okay, so on the bottom I have 3 times 3, which is going to get me 9. 3 times I gets me 3i. Negative I times 3 gets me negative 3i. Negative I times I gets me negative I squared. So then I want to simplify the bottom of my fraction. So my i's in the middle are going to cancel out. And negative I squared is the same thing as negative 1. So really I have 69i plus 23i squared over double negatives, make this a positive, so I have it over 10. Then I just want to, I forgot to, on my numerator, take care of this I squared. So I have 69i plus 23 times negative 1 over 10. going to make that 23, and since it's real, it moves out to the front, plus 69i over 10. Then I just want to go ahead and break this up into two fractions. So I'm going to have negative 23 over 10 plus 69 over 10i. Same thing on number 6. I want to rationalize this denominator, so I want to change the sign in the middle and multiply by the complex conjugate, which is 5 minus 4i. On the top, I have 2 times 5 gets me 10. 2 times negative 4 gets me negative 8i. 3 times 5 gets me 15i. 3 times negative 4 gets me negative 12i squared. On the denominator, I have 5 times 5 gets me 25. 5 times negative 4 gets me negative 20i. 4i times 5 gets me positive 20i. 4i times negative 4i gets me negative 16i squared. Then I want to simplify. So on my top, I'm going to have 10, and then I have a negative 8i and a positive 15i. It's going to give me 7i minus 12i squared. On the denominator, my i's cancel out, so I'm left with 25 minus 16i squared. So then what I want to go do next is replace my I squareds with negative 1s. So that's going to give me 10 plus 7i plus 12, because negative 12 times negative 1 turns positive. The denominator is going to have 25 plus 16. Then on my numerator, I want to combine like terms. I'm going to have 22 plus 7i. And then on the bottom, I want to combine like terms. 25 plus 16 is 41. So again, I want to split this up into two fractions. I'm going to have 22 over 41 plus 7 over 41i. Moving on to the back side. This one wants me to perform the indicated operation and write the result in standard form. Since I have a negative and a number inside the radical, I want to split these up into two. I can rewrite it as the square root of negative 1 times the square root of 144. I'm going to do the same thing over here, the square root of negative 1 times the square root of 169. Remember, whenever I have a square root of negative 1, that is going to turn into an I. And then I want to take the square root of the number inside my radical. Square root of 144 is 12. Typically, we write numbers in front of the letter I. Over here, I'm going to have an I from the square root of the negative 1. Square root of 169 is 13. So I have 12 minus 13, which gives me negative I, since I only have one of them left. So same idea on number 8, except this time I have outside numbers. I'm going to rewrite this as 3 times the square root of 36 times the square root of negative 1 plus 2 times the square root of 81 times the square root of negative 1. So then the square root of 36 is 6. Square root of negative 1 is I. Then I have that 2 on the outside. Square root of 81 is 9. Square root of negative 1 is I. Then I want to multiply. So 3 times 6 is 18. 2 times 9 is also 18. And then I have my I. 18 plus 18 is going to give me 36i for my final answer. So number 9 wants me to use Gromov theorem to find the indicated power of a complex number and then write my answer in rectangular form. This is the only formula that you have on the reference sheet for this test. So this is if I have z to an n power. It's the same thing as the polar coordinate raised to the n power. And then I would take the r, put it to the n power, and then multiply by cosine n of my angle measure plus I sine angle n times my angle measure. Okay, so I am going to use this on number 9. My r is 2 square root of 2. My theta is 315, and my n is 5. So the first thing I want to do is I want to write this out. I'm going to have 2 square root of 2 to the 5th power times cosine 5 times 315 plus 2 square root of 2 to the 5th power I sine 5 times 315. So I want to figure out what 2 square root of 2 to the 5th power is. I can break this up into 2 parts. I can have 2 to the 5th, and then I'm also going to have square root of 2 raised to the 5th power. I can rewrite the square root of 2 as 2 to the 1/2 to the 5th power. So this is 2 to the 5th times 2 to the 5/2. If I add my exponents together, 5 plus 5/2 gets me, 7/2 was right. So I have 2 to the 7th, and then I also am going to still have 2 to the 1/2 left over. So 2 to the 7th is 128, so I am going to have 128 square root of 2. So that's what the 2 square root of 2 to the 5th power is going to turn into. Then I am going to multiply the 5 and the 315 to figure out what my angle measure is, which is 1575. Then I am going to figure out a much smaller angle that 1575 can turn into. So I'm going to figure out my reference angle here. I am going to take 1575 and subtract 360. Which gets me 1215, still larger than 360. So I'm going to go ahead and subtract 360 again. Which gets me 855. Again, still too large, so I'm going to subtract 360. Oops, other way around. Which gets me 495. And if I subtract, 360 again, this should give me a number less than 360 finally. So I have 135 for my reference angle. This is going to be, I'm going to sketch this out up here. 135 is in the second quadrant. My angle, this is the 135. So to get the missing angle that I'm using for my actual reference angle right here, all the way across to that straight line is 180. So I'm going to do 180 minus 135, which gets me 45 for my reference angle. I am in quadrant 2. So I need to remember that when I am evaluating these in quadrant 2. So I still have the 128 square root of 2. Cosine of 45 in the second quadrant is going to be a negative square root of 2 over 2. Then I'm going to have 128 square root of 2i, and then sine of 45 in the second quadrant is positive square root of 2 over 2. Then I just want to multiply. So I can take this 128 square root of 2 and multiply by negative square root of 2 divided by 2, which just gets me negative 128. The reason this works is because the radical 2's, when multiplied together, turn into a 2, and then they divide out with this 2 right here. So when I do it again over here with my I term, it's just going to be positive 128.